Okie dokie. Well, welcome everyone. Happy so many people could make it to this presentation. I've had a lot of people sign up for this, so really excited about that. I think there is a lot of interest in Canadian solar panels now that we have them back on our portfolio of products we're carrying. We've had a huge success, obviously, with the Canadian Solar Inverter series, specifically the three-phase inverters, 600-volt AC inverters that we have from Canadian Solar. So we thought it would be a good idea to also bring in the Canadian Solar panels again. So with that being said, we're going to start the presentation today. We will be focusing on the CS6R series, which is the residential module, or mainly used in residential applications. We'll be carrying a fully black version of that. And the person that is going to do the main portion of the presentation is Philippe Grégoire. He is been with Canadian Solar for quite some time. Philippe, how long have you been with Canadian Solar?
Going on 8 years now.
Going on 8 years. And you've been in the solar industry for about 12 years. Got a background as a mechanical engineer, applications engineer, and product manager. And he's a professional engineer in both Ontario and Quebec. He's also supported the entire life cycle on many different products. So with that being said, I think I'm passing it over now to Jocelyn. Jocelyn, can you tell us a little bit about yourself and your role at Canadian Solar, and then also talk about Canadian Solar, the brand? You're muted.
Thank you.
No problem.
Hello and welcome. Thank you again for joining us for today's webinar. I'm Jocelyn Gerboso, Marketing Associate here at Canadian Solar. Before we get started, I will present to you a brief introduction on Canadian Solar and then just talk a little bit about what our presentation will cover today. Today's presentation will be about 45 minutes. Here is what we're going to cover today. First, Phillippe will take you on an overview of our North American module portfolio, then dive into the 8 technology advantages that make this module ideal for your installs. Before we get started, let's watch a brief video on Canadian Solar and how we are making the difference in the solar industry.
To help you make the difference, you need a reliable solar solutions partner, an international technology leader that has a proven track record for providing quality solar products and services. You'll also want a solar manufacturer that's constantly innovating and raising the efficiency bar. One that's developing new integrated products and services that make installing solar easier. And we look forward to making the difference for you and your business today and for many years to come. To help.
Okay, that was a high-level look, and here are some recent highlights. Canadian Solar is one of the leading module companies in the solar industry, a provider of complete system solutions and a developer of utility-scale solar power and battery storage projects. Canadian Solar was founded in Canada, and we've been listed on the NASDAQ since 2006. We have 2 divisions, Module and Energy Solutions, focusing on development, manufacturing, sales, and customer relationships for modules and inverters. And our energy business, focusing on the development and construction of utility-scale solar plants and projects. Next slide. We have a presence in 20 countries and territories and have shipped modules into over 150 countries and delivered over 75 gigawatts of modules worldwide. Next slide. Looking at module production, you can see how our production capacity continues to grow year after year with an expected capacity of 50 gigawatts by year end. Next slide. Canadian Solar is a world-leading bankable brand. We were ranked #1 bankable module supplier by Bloomberg New Energy Finance in the 2020 bankability survey with 100% bankability 4 years in a row. Next slide. Now I'll hand it over to you, Phillippe. So take us through the material.
All right, thank you, Jocelyn. So once more, my name is Phillippe Gregoire. I'm the Senior Technical Product Manager at Canadian Solar. I handle the module portfolio as well as the connector portfolio for the North American market. So at a glimpse, here is our current module portfolio. I'll start with the ones that are faded. Those are the ones that we've sold in the past few years, the CS3N MS modules, mainly targeted to the residential market. Those are being phased out this month. So we'll have some remaining volumes coming overseas and being sold into the market. But this is, for those that follow cell sizes, the M6 cell size, so 166 millimeter in dimension. That is now being superseded by our latest module and the subject of our webinar here, the CS6R MSHL module, so available in black and white and black on black. This one is the M10 cell. So everything with a 6 in it in our newest portfolio stands for M10, which is 182 millimeter cells. Then if we look in other market segments, so we have the big brother, let's call it, of the CS6R, the CS6WMBAG, which is a bifacial module, mainly targeted towards CNI applications or even utility. That one also has the M10 cell. I mentioned is bifacial and is much larger, so power classes around 540 watt, let's say. Then we have our flagship module, so the CS7N MBAG, that boasts our most advanced cell, the 210 millimeter cell, which is equivalent to G12 wafers. Those modules are in the 650 watt range roughly, and are mainly used in utility applications.
Part of the reason they're used in utility is because they're so large, right? They're significantly larger than anything else.
Exactly. As you progress to the right of this chart, the module becomes larger and larger. So in this case, we're talking about a module that's 2.38 meters high by 1.3 meters wide, more or less, which becomes a little more challenging to handle on rooftop, which is why we have a smaller version here for flat roof, let's call it, and a more appropriately sized residential module for that market segment.
Yeah, I just want to add, we have a mix here on the CS6s as well as the CS3s at Franken Solar. I think the black on black we have right now is still the CS3, and the black on white we have is the CS6. That's going to be transitioned fairly quickly over to the CS6 as well on the black on black side. So just keep an eye on that when you order it from us.
Thank you, Danny. So yeah, like I mentioned, the webinar is focused a little more on the CS6R. We'll field any questions that you guys have on the rest of the portfolio, but we'll mainly discuss this module. So maybe before we go deeper into the features, benefits, and attributes of the module, I'd like to launch a survey. Hazine, if you can launch the survey to understand a little better what you guys are looking for.
The survey should be launched now, so
Yeah,
everybody
it's
should
loading.
be able to see it in the chat.
I see it loading. There's a little bar going, so hopefully it'll come up.
I can see it.
There you go.
So Danny, since I'm sharing, I can't actually see the survey. I'll allow you to maybe comment.
Sure. The question is, what feature is most important to you in a residential module? High power, high efficiency, good aesthetics, high loading pressure allowance, high temperature reliability, extended power electronics compatibility, improved long-term reliability, longer warranty period.
All right, we'll give it maybe
let's see.
A few seconds for people to answer.
Okay, let's see I am curious actually about this as well. What are people going to answer? Okie dokie. Still going. People are still answering, so I'm just going to hold off another 10, 15 seconds. So looks like we got at the top, high efficiency and high power are the two top. Improved long-term reliability, followed by long warranty periods, high loading pressure allowances, good aesthetics, extended power electronics compatibility, and then last but not least, a high temperature reliability.
Okay, perfect. Well, the good news is that whichever you pick, this module has it.
It's a trick question, Phillippe.
A little bit, yes. So this here is at a high level all the attributes that the module boasts, and we'll dig through them. So you have the high power. Now, depending on which color you're getting, the power goes all the way up to 420. High efficiency. So we achieve higher efficiency than our previous portfolio through what we call the HDR ribbon technology. We'll explain what that is. We mentioned the cell sizes changing. So this boasts the latest cell size, a 182, and has a perfect size and homogeneous appearance. You'll see it in the following slides as well. We've optimized the frame and the overall module design to allow for high pressure allowances. We also follow a new standard in regards to higher temperature applications. We're obviously compatible with a variety of rooftop MLPE devices. So MLPE stands for module level power electronics, namely optimizers and microinverters. Then we have a great power generation and very good reliability, and all that covered by a 25-year product and workmanship warranty. So
which is actually something that that I've come across more and more, is that 25-year product and workmanship warranty. It's become a bigger and bigger topic, with some solar installers really trying to differentiate themselves versus the competition that sells another module that doesn't have this warranty. So I think this is really important to point out that this product does not only have a 25-year linear production warranty, but also the workmanship warranty that goes along with it.
Exactly. And that's something that we've put ourselves as a target moving forward for our residential portfolio. So let's start with the top three. So talking a bit more about power and efficiency. So before we get to that, let's look at the aesthetics. So I mentioned we have two variants. So one's a black frame with white backsheet. That's the one that gives you the highest power. Less heat, more reflection within the laminate. That's how we achieve that. If aesthetics is what you're looking for, the all black is certainly the one to consider, with powers between 390 and 405 watts. Now, beyond power, what's interesting to look at is efficiency, right? So efficiency is a measure of how much power you can get out of the module per surface area. So Danny was mentioning earlier the 3N module, great module as well. But if you were to compare both of them one side by side, you notice that the 6R is smaller for similar power. That's what efficiency is. Basically, you're able to squeeze in more power in a smaller surface area. Now, albeit it's a little wider, but all in all, in surface area, this module is smaller.
I think this is actually really important. When I started in the solar industry back in like 2012, 2013, people always talked about efficiency, and I thought it was not really that important back then because all the panels were about the same size. Like you have a 60 cell at the time and a 72 cell, they're always a meter by a meter 60 or a meter by 2 meter, and plus minus a few centimeters or millimeters even. And it was much easier to compare panel wattages versus each other because every manufacturer had similar sizes. But now every panel seems to be different in dimensions. So it's actually much more important to look at the efficiency, and it's much an easier way to compare one panel with another.
That's very true. And a lot of those module dimension changes have to do with the cell size dimension change. Obviously, there's different configuration within a certain cell size. We're not trying to make it difficult in the industry. As an industry, we try to standardize as much as we can, but there are different architecture that yield different module dimension. Danny, you brought up a good or an interesting point when we talk about cell count. Previously, it was widespread that residential module were 60 cell module. Now with the different cell sizes, that number has changed. So for example, these modules are 54 cells as opposed to the 3N, which was 66 cells. So yeah, a little bit of change in the industry. As a matter of fact, I think technology has been coming to the market much quicker in the past few years. So it's an exciting time to be in solar. And with that efficiency, if we're talking about sizes, right? Now, it also obviously has an impact on the weight of the module you'll be lifting afterwards. So you see that in this case, we're below 50 pounds, so pretty easy to handle on a rooftop application. Now, how do we reach that efficiency? So this is greatly dictated by the implementation of the HTR ribbon. So if you look at the top, this is what the interconnection between cells used to look like. So you had a ribbon that transitioned from the top of the cell to the bottom of the cell within the laminate to be connected in series. But that ribbon obviously has a cross section, a certain shape. So there's a maximum distance at which you can bring those cells against one another. If you bring them too close, then it creates a stress constraint here and starts damaging the cell, leading to microcrack and degradation over time, lower power. What we've done is change the cross section of the ribbon as it transitions to that intercell spacing. So at the top here, you have, I think it's a triangular geometry, and it transitions to a more rectangular flat cross section as it goes to the intercell gap. So instead of having a 2 millimeter and beyond gap between cells, we're able to reduce that below 1 millimeter. In essence, packing the cells closer to one another in the module and resulting in a shorter module for the same amount of cells and surface or active surface area. So now if we talk a little bit more about the frame and overall module construction design, we have our modules go through quite extensive testing to ensure that they're reliable over time. Now, the first mode that we test for is through static mechanical load tests that aims to replicate a certain event that would happen, maybe a very high wind event, like I don't know, wind speeds beyond a certain threshold that are not familiar. Or a very high snow event. Here, we recently had a nice storm that could be considered an event that causes the module to see higher load than it traditionally would be exposed to. That's dictated by standard, and all modules need to go through that to be certified. Where we differ as to our competitions is we push that further. After you've had, for example, that snow event, maybe it's not the biggest, maybe it is the biggest. Well, what happened after that is you will have wind blowing up and down on your module, basically cycling and having the module deflect up and down. What that means is that if this event induces some microcrack, when you have that cycling, then the microcrack will start propagating through the cells. And depending on how that happens, that may decrease the power output of your module. So that's why we do that dynamic load testing, basically applying a high load on the module and then cycling it, I think it's 500 times to see how the microcrack would propagate through the cells and measuring the output of the module after that. Module power needs to be within warranty limits to be considered a pass. Then the third option or mode of failure is fatigue failure. So what we do to measure that is we do fatigue mechanical load testing, which is basically modifying the amplitude of the loading we apply and repeating that for multiple cycles. So in total, that cycling test cycles more than 10,000 times, culminating in the middle to the maximum load, and then decreasing back to lower loads. So the idea is to understand how does the material react over time. I mentioned in my example where we have the wind coming and going and causing deflection on the module. That has an impact on the material resistance of the module. So understanding that is very important. And I think in that sense, Canadian Solar is one of the most conservative company that aims to analyze all these different failure modes and is very conservative in the way it approves these higher pressures and mounting methods. But despite all of that, we are still able to develop a strong module that can sustain those high snow loads or wind loads. Now, throughout these tests, we do what's called a flash test to measure power output and EL testing. So EL testing is electroluminescence testing. It's what this image shows, actually. You get to see when injecting current within the module and taking a picture through different visible bands or frequency bands. You get to see how the cells are cracked or not cracked or have unproductive zones. So we do that to make sure that we have a complete understanding of how the module behaved after the loading. And lastly, well, we apply a 1.5 safety factor that's actually dictated by standard, and that accounts for material manufacturing variability. Evidently, not no, all aluminum is exactly the same. There's always a little bit of variation in the concentration of whatever elements that's within the aluminum alloy. So the standard dictates that there be a safety factor to take that into account. So what that results into is basically what I'm showing here. This is the maximum load that the module can achieve in the best mounting scenario. So this is what I'm showing at the bottom right here. So you have 8,100 Pascal downforce and 5,000 Pascal uplift. Those are test loads. And you can see here, we've depicted it in the manual. So this is the clamping range that you're allowed to, measuring from the side of the module to the clamp. And we have other clamping areas if you need more flexibility. Obviously, the closer to the edge you are, the less pressure the module can sustain. But depending on what you're looking at doing on your roof, that may be useful. Now, how were we able to reach those higher pressures? So it was through iterating different cross sections of our module. We've played with the thickness of a return flange, the length, thickness of the profile, the lips, the width of the cavity and whatnot. All of these have an impact on the module's ability to resist those higher loads. Furthermore, especially when we're talking about downforce or snow loads, it's important to have some support. So we have this back bar on the back that helps limit the deflection and allows to reach higher pressures. Now the manual will show you all the mounting configurations you can mount for and what's their respective mounting locations and pressures. But there are some specific mounting systems out there that are less generic, let's call them. And with those companies, at times we will issue what are called product letter approvals. So if you're looking to mount with a popular mounting manufacturer, let us know and maybe we have a letter. If for whatever reason you do not find your mounting method in the manual, and it's very important that your project has certain parameters, we can always look at granting project level approvals. I will warn you, it's a process that takes a little more time, so we do encourage people to look for mounting methods that are covered by the manual or the product letters we already have. So I mentioned that we have a few product letters. So here I'm giving you an example of the different mounting configurations we have and what manufacturers those are. So if we look at rail support with 4 or 6 clamps, so you have Iron Ridge, Unirac, and others that provide this type of mounting solution. So that could be something to be considered. Iron Ridge specifically has mounting from underneath the module. Not ideal, which is why you have a lower pressure allowances, but better aesthetic look. So some people prefer it. Similarly, there's short site mounting for those projects that need maybe the module to be installed in landscape. And then I'm not sure if that's as popular in Canada because the pressures are a little lower due to the mounting points being more or further apart. But there's also railless options that are a little more popular in the US. Companies like EcoFasten, Snap and Rack, and I think there's others as well, where the idea is that you don't need the rails, and instead you just have the anchor point be the clamping point as well with some interlock between modules. So we have options for landscape or portrait orientation. I'm sorry, Danny, did you want to comment before I go into the next
quick
one?
question, actually. If you can go back to the clamping points, the first slide there, the clamping points, into short side clamping. Is that specifically to your 60 cell, or sorry, residential module, so 54 technically, right? So is that specifically to that module, or is it also applicable to your commercial modules on short
Yeah,
side?
so these scenarios with these pressures, this is applicable to the CS6R specifically.
Sure. Okay.
We may have other modules that are covered on there, but they would probably have different pressures.
Gotcha. Makes sense.
All right.
And yeah, railless is, I think it's becoming more and more of a topic up here. There are some limitations, obviously. and some challenges in an environment that has a lot of snow in many places in Canada, right? But I think it's becoming more and more of a topic, and at that point, it's definitely good to have that.
True, and sometimes people forget that it's not just the mounting from the racking to the module, but also in these instances, sometimes you have too much of a span between rafters.
Yeah.
That's where rails might be more useful, that you can put the number of L feet you need without needing to mount at that point with the module as well.
Although nowadays a lot of residential anchoring points actually don't connect to the rafters anymore. They're just going to the decking. So it's
True.
becoming, less of an issue on that side. I think like products like Rooftop have become market leaders for that very reason, because it just allows for a lot more flexibility. But yeah, we'll definitely. I fully expect to see more and more railless solutions in this market.
And Rooftop could be a good choice. They follow our
Yeah.
manual guidance and would be compatible with us.
Perfect.
Okay, let's talk about IEC 63126. I talk about it not because it's required, but because it's a nice feature of the module. So basically, this standard is being used in other regions of the world. It's expanding the severity by which the module is tested as compared to just a certification testing. We do that, more severe testing and even beyond that standard internally for quality purposes and reliability testing in general. So whether we follow the standard or not, we are covered and know that the module will last for the applications we sell it into. That said, the certification does kind of vet that it's been tested for certain parameters and is third-party verified, certified, if you will. So what that says is that for 98% percentile of the temperature that falls below 80 Celsius, if we look at rooftop regions, this module is certified under those conditions. So for Canada, obviously everything's covered. For the US, I think it's probably 99%. I think the only area that's not covered is the Phoenix, Tucson area. So basically, you're able to claim that the module has been going through more severe testing sequences under this new standard. So it is well applied for high temperature environments and will perform as it should for the years to come. So quite technical. I won't go into too many details unless there's some questions. What I'll do is go into MLPE and compatibility. So with the different cell sizes comes different electrical parameters. So this is what I'm showing here on the right. So you may see that the voltage is different as opposed to an M6 module is a little lower. The current, therefore, is higher, which means that the pairing with your MLP devices might be slightly different. So we recommend that you check with your MLP provider to make sure that the pairing is suitable. That said, we do take a look to make sure that we have some units that are compatible with our module. And I've named here some of these manufacturers that are typically being used. Those portfolios are ever continued changing as any manufacturer. So I know SolarEdge has been launching their new S portfolio and Phase their IQ8. Tygo has been expanding their current offering to be more flexible, and I'm sure Hoyer Miles and other manufacturers are doing the same.
Yeah,
So,
and from those we don't carry SolarEdge or Enphase, but for Tygo carry the single Tygos, and then Hoyer Miles we carry the HMS series. So I think they would the panels would work with all the HMS series. Shouldn't be a problem there.
exactly, and we're not the only ones to have 182 millimeters. So
yeah.
Pretty much every MLPE supplier has a solution for it.
Yeah. But definitely something to keep in mind too when you're looking at your string inverter or anything. The current is definitely it's higher than what traditional modules have been. We're looking at here is almost 13 amps, right? So, or even sometimes over 13 amps, right? No, IIC current is way over 13 amps.
Yep.
So just make sure, regardless if it's string inverter or panel level power electronic, make sure that your equipment can handle it with all of these new panels, not just Canadian Solar. Anything that uses an M10 cell, make sure your power electronic you're using with it can handle it.
Yeah, I think that's good advice in general.
Yeah.
Okay, let's talk about power generation and reliability. So I mentioned earlier micro cracking, so trying to explain it here in greater details. So for those that have been around for a few years, you probably remember the 5 bus bar modules, right? Just, I think, was it 3 or 4 years ago, probably, 5 bus bars were still pretty popular, and we still had full cells. Now where we're at is multi-bus bars, so we stopped counting at this point, right? So it's just the M that stands for a variety of numbers, and we've split the cell as well. So if you look at the microcrack that starts here and then spreads, it will spread and probably terminate at the bus bar on one side and at the edge on the other side. But now, in theory, you have a large area that's inactive. So probably this surface here. So the fingers here can't reach the bus bar. So you've got this triangle there. Whereas if you have multiple bus bars, well, now the bus bar is closer to the edge and closer to wherever a crack may start. So that triangle becomes smaller. Same happens with splitting the cell. If it started in the middle here, then it will spread until it finds an edge, potentially. It doesn't mean it will stop at the bus bar. The bus bar will actually just be a point of collection that allows the fingers to carry the electrons and generate the power. So if it goes through the bus bars and finds another edge, you can see that now you may have more of those inactive surface areas. Whereas if you had the same starting point somewhere in the middle, if it terminates quicker, now you only have half of that cell that's affected. The other half cell is unaffected. So all of that in the end yields better or more power over time, or less loss of power over time, if you will. All modules with polymer backsheet will be subjected to microcracking over time, but the question is how well do you sustain it and how much of that affects your power. In the case of Canadian Solar, like I mentioned earlier, we do a lot of testing to measure all that, and power degradation over time is minimal in that regards. Other testing that we do, I'm not sure for residential if it's been as much of a concern, but in the industry in the past few years, there's been some concern over what is called LETID. LETID stands for light and elevated temperature induced degradation. Quite a mouthful, but basically something that happens to the cell when it's first exposed to light and then in conjunction with high temperatures. So some may be familiar with just LID, which is light-induced degradation, which happens in the first few weeks. We have very low LID on our modules. And we also measure for LETID, which happens over a period of a few months to a few years. And as you can tell, our modules perform much better than the industry standard. We're at half or below half in some cases in terms of how well we resist to it. So that's not shown in the data sheet, but something that will affect the module in the field. So important that you have a reliable partner for that. Same thing for safety. So hotspot temperature resistance or hotspot resistance is something that's important as well. So maybe the most general scenario in which that could happen is you have your modules on a roof and it's fall, you have a leaf that falls on your module and covers a full cell. Now, depending which cell it covers, the rest of that substring will need to, or will feed into that cell that will need to dissipate that heat since it's not producing. If you don't have a module that can resist that hot spot or that rising temperature very well, it may create a hot spot leading to damage on the backside of the backsheet and potentially damaging the module. So we've done a few things at Canadian Solar to prevent that. In the previous cell, I mentioned cutting the cell. That's one mitigating strategy that reduces the current and therefore the resistance and the amount of heat that needs to be dissipated. Another method is as well just measuring the resistance to that heating of the cell at the factory. So that's what CSI stands for. It's infrared measuring that basically looks at which cells are more prone to that damage than others, and being able to basically limit the distribution of the number of cells that we use in construction of our modules to something that's more acceptable. So when we put all of those together, that's how we're confident in being able to provide a warranty that lasts for 25 years. Danny mentioned earlier that we've increased our product workmanship warranty from 12 to 25. That's applicable to this module and rooftop applications for our markets here, Canada and the US. It's coupled to the performance warranty. So you can see that on the first year, the warranty or degradation should be lesser than 0.55, or sorry, lesser than 2% on the first year and then 0.55% in subsequent years, which means at the end of year 25, you should be above 84.8%. So if we try to summarize what we've seen, so what you get with this module is great aesthetics, for a superior look. That's what we see here as an example in the house here. You've got very high pressure allowances with a variety of mounting methods. We saw all the different scenarios and pressures you can reach. Power density, we talked about the efficiency, which gives you a smaller module at lower weight for high power. Got increased reliability through all the different mitigation and checks that we do internally at our factories. You're compatible with a variety of different MLPE options out there, and all of that's backed by that 25-year product and performance warranty so that you have peace of mind. All right, so with all of that said, Hazine, if you could launch the last poll, I'd like to get a feel for what people are looking for in the next iteration of that module. I mentioned that the industry is moving forward quickly, so there's a lot of innovation that's coming to the market, and we all want to be able to take into account your desires when we design new modules. Hazine, were you able to launch the survey?
It's up there. It's up
Perfect.
there. Yeah.
Okay.
Okay, I'm going to read it quickly. What features should be improved further for the next generation of residential solar modules? And it was high power, high efficiency, good aesthetics, high loading pressure allowances, high temperature reliability, extended power electronics compatibility, improved long-term reliability, longer warranty period, and none. This is the module I need. Well, I hope everyone presses 9, but in this industry, we always are trying to improve, so I doubt that is going to be the case. I mean, it's funny, like looking back. I mean, many of you, I'm sure, have been in this industry for a long time, and I personally started 2012, I think it was, and I think my first panel I ever sold was a Canadian Solar 225 watt. And I know that there are many people that started before me, and they started in the 150, 180 watt range, or even lower than that. And we certainly have come a long way from 200-ish watts to now on a residential north of 400 watts. Commercial utility, we get into the 600 plus watts for a fairly readily available module. Of course, there's always the specialty application ones that you can get out there that are higher, but I mean, for what is a good module, we're getting quite high. So it's exciting, and I'm sure it's not going to stop anytime soon. We're going to keep seeing more and more improvements. Yeah. What do you think we're gonna Phillippe? Do you think we're gonna crack the 600 watts on a commercial CNI product in the next few years?
For sure. Yeah, we're already working on that, so you should see that in the coming years.
Nice, that's exciting. I guess some things that there's lots of stuff out there. You're mentioning the gap between cells, so you're down to a millimeter. I've heard companies talk about shingling, which I think has some issues with it, right? where with like you were mentioning about when you get too close, you may start seeing some cracks forming from pressure points and things like that. So I guess that has to be figured out first before we get into shingling of cells.
Yeah, the shingling is an interesting concept. We've done that. Actually, we still do it. That's what we
Yeah,
manufacture in our Guelph factory.
yeah,
But yeah, it certainly comes with its cost challenges. So
yeah.
for now, we're moving towards half cell as a general strategy.
Yeah. Cool. Okay, so let's see what people answered. So top on the poll was high efficiency. There you go. So you got to keep getting higher on the efficiency side. High power, which kind of goes into similar idea, followed by improved long-term reliability, extended power electronics compatibility, good aesthetics, high temperature reliability, high loading pressure allowances, longer warranty periods is last, which I guess means your warranty is pretty damn good. That's good to hear. Awesome. Can you go to the next slide? I know there was a question too. Before we get into the actually, is there a slide afterwards about questions? So I think
We
that was
can
at the
certainly
end.
take
Okay. No, let's
questions.
go quickly to how to contact, and then we'll get to the questions.
Okay.
So obviously, you can reach out if you have any questions to Canadian Solar. Best way would be sales.ca@canadiansolar.com. Alternative, if you have any questions, we'd be very happy to help out at Franken Solar as your Canadian Solar distributor. You can reach us at sales@frankensolar.ca. My email is danny.mueller@frankensolar.ca. You can call our office, or if you have an account manager already that you're working with, just feel free to reach out to them and ask them questions that you may have. Now to the question, Barry asked, the highest efficiency that can be reached will be 21.5% question mark. I guess on this module, let's see the data sheet.
Yeah, I think that's what we had here for the 420. That was
420 is
21.5.
yeah, 21.5% efficiency of the entire module.
Yeah, and I don't have it here, but to your point, Danny, it is displayed on the data sheet if you want to look up other
and I
power
put the
classes.
data sheet in the chat. So the 395, for example, which is kind of where we're at right now, as a module efficiency of 20.2%. As this product kind of goes through its lifespan, generally what we will see is that the wattages will go up as time goes on, as the cells get a little bit better. That's generally what happens when we see modules, start to, coming to the end of its life cycle, or when I say life cycle, sales cycle, I guess we should say, or production cycle, and then eventually it'll be replaced with a new module by the manufacturer. Then there was a question by Natalie. What is future for solar modules looking like with larger cells? Will they continue to get larger?
That's a great question. So yes, they've been growing the past years. There's no reason to believe that we've reached a maximum. That said, there is somewhat of a, I don't know if calling it a plateau is the right term, but in the near future, there's no new cell size that we envision greater than the 210 millimeter / G12 wafer. In terms of technology, so I guess you could look at it from different aspects, right? There's cell improvements and then there's module improvements. In terms of cell technology, currently we're at PERC. This is what this module is, so monofacial PERC. We are going towards TOPCon N-type wafers. So in the next year or so, you probably will start seeing that into the residential market space as well. So that will bring on another slew of benefits and improve efficiency furthermore.
Dennis had a question about fusing breaker sizes, what do you recommend for minus 25C? I guess that is not a module related question. You don't need any fuses on modules generally. Guess that would be depending on your inverter and your application. Many times we don't use any fuses on inverters at all. So that would really depend on your AC infrastructure.
So maybe just to expand on that, I guess the reason why we don't see fuses very often is typically for residential. You have 2 strings or less, so there's no backfeeding of 2 strings into one. If for whatever reason you do have 3 strings, then you would need to protect the strings with fusing. And the data sheet shows the fusing, max fusing that would be required. Obviously, you could go smaller, but this would be a recommendation.
And I think we actually carry that product too, the 25M fuses in our online shop. But like I said, it's not something we typically see very, very often anymore. That is more a thing from the past, and most inverter, like you're saying, are not using fuses, a fuseless concept, because fuses trip, right, or break, and then you have to go to the field, and it's not very efficient that way. So whatever we can, oh, there you go. It's an off-grid application, so that makes sense. Then Barry asked if there was a bifacial version of this module.
No, there isn't. I guess I will highlight that the cells are bifacial. So as a large manufacturer, I think bifacial became more popular in 2018. All our modules have bifacial cells. So that's another improvement that yields slightly higher power. That said, the construction is a monofacial construction. So there's no bifacial gain that you'll get through it. It just helps us increase the power of the module as a whole.
Yeah, and the commercial modules are all bifacial, I believe, from Canadian Solar. And yeah, the resi, I guess, there's typically not that much benefit in a residential module being bifacial, as most of the time it will be installed on a residential roof, which doesn't really get you much light from the backside, as it will be typically dark surface behind it. So the benefits will be from the dual glass side. Dual glass also has some downsides, especially in transportation. We have generally, I don't know, not necessarily with Canadian Solar, but we have seen dual glass modules have a higher break rate, especially if they're coming in partial skits, especially, or if you have to transport them. For residential may also be a little bit of a downside if it's a dual glass module. Good. If there's no more questions, if people have more questions, please feel free to ask it now. Otherwise, we'll go close this up shortly. Dave is asking that he didn't catch when TopCon technology will be available for Canada under 500 watt residential size. Do you have any timelines on that at this point?
A little too soon for now. Probably
Yeah.
will be in 2024, but when, that's hard to tell at this point.
Yeah, that's what I'm hearing as well, is that, even from other manufacturers, I don't think there's anything going to be available this year. So it'll be more down the road in general. I guess it has to do with costs as well, right? I'm assuming.
Yes and no. So obviously, you look at a manufacturer like Canadian Solar and some of our competitors, there's just a high sheer volume of equipment that we have.
Yeah.
So we're not capable of upgrading all at once and just switching the switch overnight. So there's certain markets, certain technologies, certain regions that are targeted first. And then eventually we have the whole manufacturing process that's upgraded, and then that becomes the default offering.
Gotcha. Excellent. There's also a quick feedback form. If you can take 30 seconds and click on the link that Haseen just posted in the chat and just quickly fill that out, we'd very much appreciate it. We're always trying to improve these webinars. And any feedback we can get at Frank and Solar would be greatly appreciated. So Thank you in advance for that. Also want to use this opportunity to remind people that we've got a warehouse show coming up in April 26th, 27th here in Brampton, Ontario. We'd be happy to have you. Haseen just also posted the link for that. If you want to sign up or you want to see what's going on there, there's a number of really cool things going on there. We'll have some presenters really from across the globe. We've got people coming from Europe, across North America. There'll be a networking opportunity in the evening as well. We're going to go bowling with everyone and have some drinks and food and everything. So Canadian Solar will be there as well, presenting their inverter series specifically, talking about the 600 volt AC inverters that are the #1 commercial inverter in Canada now. So please come if you're interested, sign up, let us know in advance just so we can make sure there's enough food and drinks for everyone. And yeah, so thank you, Phillippe, for taking the time today to talk to us about your residential modules at Canadian Solar. Really excited. We do have them in stock. If anyone is interested, please reach out to Franken Solar and we'll be happy to help you out.
Well, thank you for having us, Danny.
No worries. Have a good day. Bye-bye.
Take care, everyone.
Thank you.